In the last session, we have tried to state the second law of thermodynamics in terms of the limitations given to the working of two of the common engines, namely the heat engine as well as the refrigerator or heat pumps. So we have seen that the statement of second law of thermodynamics is basically a negation or a negative statement, and it says that certain processes are not possible even though the first law of thermodynamics or the law of conservation of energy does not actually block the process to happen, or it is permitted. Even though it is permitted by the first law of thermodynamics, certain processes are not occurring in nature spontaneously. So that is the basic explanation of the second law of thermodynamics. So in terms of the working limitations of a heat engine, we have stated that the efficiency of a heat engine can never be unity or 100%. We can never achieve a 100% efficient heat engine. That is not possible. And in terms of the working of a refrigerator, we have stated that the coefficient of performance of a refrigerator can never be infinity. That was our explanation. Now, as I told you before, that there are several formulations of the second law of thermodynamics, and a precise statement of the second law of thermodynamics was given by three of the scientists, and actually they gave their statements independently, but later these statements were actually combined based on whether they are talking about the working of a heat engine or they are talking about the basic limitation of a refrigerator. So you can, as you know, or you can see that there are three people involved in giving a concrete statement of the second law. They are respectively Kelvin or Lord Kelvin, better we call him Lord Kelvin, and Max Planck. So you can, whose photographs you can see here. Lord Kelvin. This one is Lord Kelvin, and this is Max Planck. After whom we are using the Planck's constant H. And another statement was given by Clausius, Rudolf Clausius, and this is Clausius. So now the second law of thermodynamics is basically known after these people. So we will see the Kelvin Planck statement and the Clausius statement separately, and we'll discuss what actually they tell. Now, as I told you, Kelvin and Planck actually had made their own separate statements, their own understanding. And later these statements were combined to make what is known as the Kelvin Planck statement of the second law of thermodynamics. So let's see the original statement that was made by Lord Kelvin, and maybe we can see the language. It's a bit you can see technical, but the essence will be the same as what we have discussed before. So let's go through the original statement made by Kelvin, and let's try to understand the statement word by word. So it will always help us how the original statements were made and all, right? So let's say let's analyze it. So this is a statement. Let me read it for once. It is impossible by means of an inanimate material agency to derive mechanical effect from any portion of matter by cooling it below the temperature of the coldest of the surrounding objects. So this is the original statement. Maybe you will have to contemplate on this lengthy sentence, maybe breaking into different phrases. You can just get the meaning. So let's say what actually it says. Always remember one thing whenever you read the Kelvin statement. I told you that in simple terms you can always relate the second law of thermodynamics either to the limitation in the working of a heat engine or to the limitation in the performance of a refrigerator. So always remember, Kelvin's statement and Planck's statement are related to the limitation in the performance of a heat engine. So whenever you read the Kelvin statement or you read the Planck statement, have a background picture of a heat engine in your brain. So it will be quite easy to understand then. Okay. So let's see now what actually it says that. So it's impossible. So as we have already seen and stated multiple times that the second law of thermodynamics is always negative statement. So it is saying that something is impossible. It's impossible by means of an inanimate. Inanimate means non-living, right? Okay. Inanimate material agency means some external agency to derive mechanical effect. To derive mechanical effect. Deriving mechanical effect means obtaining useful work. Okay, so that's the meaning of this term. Derive means obtain or get. Mechanical effect means what? Useful work. Because our basic aim of a heat engine is to obtain useful work, or work should be done by so no, not okay, just on the thing, and should be done by the engine, right? So useful work from any portion of matter. From any portion of matter, you can take it. This matter can be just compared with something like the working substance that we are talking about in a heat engine, working substance. So this is the way in which they have used. This is their original statement. Okay, from any portion of matter by cooling it. By cooling it means I'm drawing heat, right? By cooling it means what? I'm drawing heat below the temperature of the coldest of the surrounding objects. Below the temperature of the coldest of the surrounding objects. Okay, so coldest of the surrounding objects. So that's all talking about. Okay, see, coldest of the surrounding object means what? It says about what you say, the sink that we talk. Okay, is not sink, right? So you cannot just obtain mechanical work, okay, right? Is not by drawing just heat. Is not by drawing heat. That is what we cooling it below the temperature of the coldest of the surrounding objects. It says that you can't have mechanical useful work derived from a system by using a single reservoir. That's actually the mean, by using a single reservoir. So let's go to the Planck statement and then we will connect it better, I think. Okay, so let's see what actually Planck stated. This is the original words of Max Planck. Okay, it is impossible. You can see that that's characteristic of the second law. Okay, it's impossible to construct an engine. Here it is more direct. Okay, he's talking about an engine. It's impossible to construct an engine which, working in a complete cycle, means it's cyclic, it's undergoing a cyclic process, will produce no effect other than the raising of weight and cooling of a heat reservoir. So okay, let's see what it means. Raising of a weight. What do you mean? Like just you have got some weight, you say. You have got some weight. You say that this is some weight W. Okay, of course that is some mg. Okay, W equal to mg as usual. Right? That's weight. And you have some, say that I'm having a machine like this. This is some pulley and I'm connecting this rope to the weight. Okay, right? See? So what is meant by raising of weight? Raising of weight means that if you are raising this weight by certain height, say h, okay, then you know that you are doing some work. What is that work? Work will be equal to, remember, do not confuse this W with the weight. Okay, I used W here for weight, and this W stands for the work. Okay, W equal to, you know, that will be equal to mgh, right? That will be the change in potential energy. that is a work done to raise the mass through a height equal to h. So raising of weight here means doing work, right? So this is one effect. Okay, what is the second effect he is talking about? No effect other than raising of weight and cooling of a heat reservoir. Cooling of a heat reservoir means, okay, suppose that you have got a hot reservoir, what do you call a source. Okay, so suppose that there is a source and a source of heat, you are drawing or you are just taking some heat out of it. So means, usually we call it as QH. QH is the heat that is drawn from a heat reservoir. Okay, so the heat reservoir will be getting automatically cooled down. So I can see that QH is drawn. So these are the two processes that he is mentioning. Okay, now let's read the statement once again. It is impossible to construct an engine which during its working in a complete cycle will produce no effect other than the raising of a weight and cooling of a heat reservoir. So it's quite clear now, it should be quite clear by time, that there will not be any engine which produces only these two changes. What are the changes? It's drawing certain amount of heat from a reservoir, thereby cooling that reservoir, right? And using that heat to perform some work. So what does it mean? Some QH is drawn and that entire QH is converted into some useful work. Means nothing else happens. So what is missing here? I told you the background is about working of a heat engine. You know what is the basic principle of working of a heat engine? There are three things, always remember, that already we have discussed. So QH amount of heat is drawn from a high temperature reservoir. A certain amount of work W is delivered, and always there will be a left out quantity. There will be some left out quantity of heat, which we have labeled earlier as QL, and this QL will be always there. Means QL is never equal to 0, and this QL should be delivered or rejected to what is known as what? A low temperature reservoir, which we call as what? Sink. So you can see that in the Planck statement, the engine is having only these two things. Only it is having a high temperature reservoir and it is performing work. Means only one reservoir is there in this particular engine. That Planck is saying is not possible. It is not possible to construct an engine working in a complete cycle will produce no effect. Okay, it only produces two effects, no effect other than the raising of a weight and cooling of a heat reservoir. Such an engine is not possible. Okay, and is not what we have already discussed in the previous sessions. Okay, we mentioned that the efficiency of a heat engine equal to 1 minus QL by QH. You will see that these are all one and the same, but put in different language. Okay, and we mentioned that eta can never be equal to 1. Okay, and for eta to be equal to 1, you have seen that QL should be equal to what? 0, but QL is not equal to 0. QL can never be equal to 0. And the same idea is here. It is not possible to have such an engine where QL is equal to 0. Okay, so the same meaning is implied here, right? Now maybe for people like you and me, or who are not the native users of English language, maybe it is quite it's somewhat difficult to reproduce these statements as such when you state the second law of thermodynamics. Okay, because it's a rather lengthy statement, and if you miss out maybe one or two terms there, maybe its meaning will be lost, right? So it's better always that we restate Kelvin statement and Planck statement in a combined manner, which is rather simple. Okay, that is what I have done in the next sentence. Okay, that is the way in which it is usually also observed in your textbooks, right? So let's see what is the refined form of Kelvin Planck statement, which maybe you will be able to better reproduce anyway. So go do it. So it's impossible again. So it's impossible to construct an engine operating in a cycle. So that's all the part of the beginning verses of Planck's statement. Operating in a cycle will produce no effect. You can just compare with the Planck statement, other than the extraction of heat from a reservoir. Okay, that also is mostly that of Planck, and the performance of an equivalent amount of work. So it's mostly the Planck statement. What Kelvin meant is also is the same. So this is the rather reproducible statement for us to digest also easily. It is rather impossible to construct an engine operating in a cycle will produce no effect other than the extraction of heat from a reservoir and performance of an equivalent amount of work. So then that is quite evident. There is no words such as raising of a weight and all, because at the times of Planck and all, raising a weight was understood to be another term used for doing work. That's all, because raising weight is equivalent to doing work. So this is the thing, means you can't in a sense you can see that you cannot draw certain amount of QH from a heat reservoir, and you can't convert this entire QH to W. If you are converting QH entirely into W, then we say that QL is 0, right? Okay, or there is no any role of sink there in that particular engine, or we will say that eta is equal to 1. So these two things are not possible. That's what Kelvin Planck's statement says. And hope you remember we started about this particular question in the beginning of our module. Can we convert heat completely into work? Even the work can be 10% converted into heat. We concluded that heat can never be converted completely into work. That same thing it's being stated by Kelvin Planck's statement. Now, maybe for those who are not confident of reproducing this Kelvin Planck statement, may go for another alternative statement, which is quite simple for everyone to reproduce and write. So this is what is given here, and that is the most common. Okay, it's for the layman. For even though you don't have much physical understanding of the things, you can reproduce it. Okay, so that's quite some simplest of all statements is given here. Let's say what's that? It's saying that no process is possible whose sole result is the absorption of heat from a reservoir and the conversion of this heat into work. So again the negativity creeps in. No process is possible means it's impossible. Okay, there won't be any such process in nature whose sole result, sole means only, means it produces only this result, nothing else. Whose sole result is the absorption of heat from a reservoir, that is QH is drawn, Q is drawn from a reservoir, and the conversion of this heat means completely into work. Okay, and it's not again meaning that you cannot convert any heat drawn completely into work. There should be something left out. There will be always some wastage. I cannot say wastage. Okay, there will be some amount of heat energy, and that will be always rejected. Okay, means the efficiency can never be equal to 10% or eta is not equal to unit G. So that's, I think, the statement of Kelvin and Planck. So you may be able to maybe repeatedly reading and understanding and contemplating, you will be able to reproduce any of this statement with some effort. Okay, at least the last one, see that at least you have the last one with you. No process is possible whose sole result or whose only result is the absorption of heat from a reservoir and the conversion of this heat into work. Remember, being a statement, okay, whenever it is asked for the statement in exams, see that you try to reproduce the statement. Okay, whatever I have given in red, either the first one or the second one, okay, you try to reproduce it as such. Okay, and you may explain it like what we have been doing so far. So if you're asked to state and explain, then see that this is a statement, you give the statement and then you give the explanation for that. Okay, using whatever symbol or schematic diagrams, you can give an explanation. That will be always better. Okay, right. So rules and laws are to be just stated in its own standard wording. That's always better. Now, before I end up the Kelvin Planck statement, let me just tell you one more thing, or its implication. So I told you that always a sink must be there, to which some small amount of heat has to be rejected. So it takes you to another question that we have already discussed in the previous session, that can a ship run by itself, by its own, drawing heat from the ocean and converting that heat entirely into work? And the Kelvin Planck statement readily rules out this possibility. And you can see this scenario. That's only for you to remember. This diagram has been reproduced from a website of ohio.edu. See, so that that's there in your mind. This concept question is there in your mind. So you can see, what does it show? It shows just a simple boat. Okay, and see, from the ocean, some heat Q is shown to be drawn, and the ship is equipped with, or the boat is equipped with a special type of engine which converts this heat entirely into work, and it works. Okay, so this is a hypothetical engine, I should say. It's a hypothetical engine which is converting the entire heat that is drawn from the ocean into work, and thereby running this thing. Okay, so even though the ocean is a very giant reservoir of internal energy, such a ship is not possible, because it is it's not permitted by the second law of thermodynamics. That's a very basic thing. So this scenario is impossible. So you can never have such a thing realized. Actually, many people have thought of the possibility of having such a thing. That is why such a question has become something. And there are reasons, because here, what is the major problem? You know, where this Kelvin Planck statement is in here in this example, because here you can say that there is only one reservoir here. Ocean is the reservoir, single reservoir from which it is there. There is no sink here. Okay, and there should be always a sink which will be just a low temperature reservoir. You can even talk about think of the surrounding air, but usually the surrounding air in during daytime, the surrounding air will be usually having a temperature higher than that of the water, so it is not a cooler reservoir. And anyway, the efficiency eta of this heat engine can never be equal to unity. So that was about the Kelvin Planck statement of the second law of thermodynamics. Okay, we will discuss the equivalent statement given by Clausius in the next session. Thank you.